So we just finished a fantastic few segments, and now it's time for some questions. But before we dive into that, we have our math challenge. So I hope you're ready. I hope you're excited. And this one is called the fireball problem. Okay, so let's go ahead and take a look at what's going on here. So first things first, we can see that we've got two lizard-looking things. Okay, so I've got lizard 1 and lizard 2. And both of these lizards are firing out some fireballs. Okay, we can see that. There's some fire going on here. Pretty spooky. This is the mama lizard and this is the baby lizard. And the baby lizard's fireball looks a little bit like a flower. Okay. Now, what we want to do here is notice that in each of these fireballs we have a perfect sphere. Okay? So these are two perfect spheres. All right, not a circle, but a three-dimensional sphere. All right? So we have sphere 1 and sphere 2. And the fire is wrapped around this, right? That's where the fireball is. This is the ball within the fireball. Okay? And we're given an equation for the volume. Okay? The volume of the ball that is at the center of this fireball. Okay? So we get V is equal to 4 pi times r cubed. Okay? And here we can estimate, okay, we can approximate pi to about 3, okay, just to make it a little bit easier for us. Okay, you can estimate pi to about 3 if you need to. And we want to know, r here, of course, is the radius of the sphere. So from the center of the sphere out to the shell is the radius, okay? So we have R1 for the mama lizard and R2 for little baby lizard, okay? And we want to know, given that the radius of the mama lizard's fireball, okay, is 3, and the volume of the baby lizard's fireball is 8/27 times the volume of the mama's fireball. What is R2 of our baby's fireball? Okay, so that is your challenge for today. You can go ahead, take a crack at it. I think that this is kind of a fun one, right? Just so that you know, these baby lizards mature in about 3 years. So it gives you kind of like an interesting, in 3 years, how much bigger is this fireball going to be, right? It's going to be 27/8, which would be approximately a little bit over 3 times, right? A little bit over 3 times. So the fireball is going to get almost like 3 times bigger in 3 years after they reach mama size, which is pretty cool. Yeah, but tell me, what is R2? Okay, what is R2? The radius of the sphere for the baby lizard's fireball. So that's your question for today. I hope you enjoy. Don't go anywhere, because up next we've got some questions, engineering tributes, and maker highlights. So stay tuned. fireball solution. So if you remember when we left off, we had a mama lizard and a baby lizard, and they were both shooting fireballs. And within these fireballs were actual spheres, and we had the radius of these spheres, and we had an equation for calculating the volume of each sphere. And we were given R1, which is the radius of the mama lizard sphere, was 3. We were given the proportion of the volume for the baby's fireball to the volume of the mama's fireball. And we said that it was about 8/27. And we wanted to know what was the radius of the baby lizard's fireball. So let's go ahead now and work on solving this problem to find R2. Okay? So first things first, I am going to look at this equation right here. Okay, so V2 equals V1, and we're going to substitute our equation here, V equals some function of R, for these two V1s and V2s. Okay, so we're going to start with V2 is equal to 8/27 V1, and then I'm going to plug in this equation for both. So we can plug in 4 pi R2 is equal to 8/27, that should be cubed, 4 pi R cubed. Okay, and remember we're trying to solve for R2 here. So the next thing that I can do is I can plug in 3 for R1. And I can actually, before I do that, I'm going to cancel out those two because I notice that they're both on both sides. So let's write this now with the canceled out pieces, and we'll substitute R1. So we have R2 cubed is equal to 8/27 times 3 cubed. Okay? And what is 3 cubed now? We're getting there. 3 cubed is equal to 3 times 3 times 3. And 3 times 3 from your times tables is 9. And we know that 9 times 3 is going to give us 27. Okay, so 3 cubed is equal to 27. So I can just write here 8/27 times 27. And we're going to notice that those cancel out. So R cubed over 2, R2 cubed, rather, is equal to 8. Okay, so now we need to take the cube root of 8. Oh my gosh, this seems really tough. But if you might have noticed, 8 is actually very easy to get the cube root of, because the cube root of 8 is actually just 2. Okay? 2 times 2 times 2 equals 8. So let's go ahead, let's take the cubed root of both of these. That's going to equal R2, which is equal to 2. So that is our answer. So R2 is equal to 2. So I hope that you enjoyed this problem. It was a little bit of a fun one. We can see that the radius has only gone up by a half. Okay, it's only gone up by a half of what it was from when it was a baby up to a mama. But we'll notice that the volume has changed drastically, right? It's 3 times what it was, almost. It's a little bit more than 3 times what it was, right? Once they become fully grown. So that's interesting that the radius doesn't change that much, but the volume changes quite significantly. And that should be something that you take note of, because this is sort of an important relationship. for different volumes and areas in three-dimensional space. So that concludes our fireball solution. I hope you enjoyed, and I'll see you in the next one.